All right, you guys, I am looking at my Unit 7 planner because we are now starting Unit 7, and I have you scheduled for doing Unit 7 Module 1, Session 2, because we're skipping that pretest on Friday, tomorrow. If you're not going to do it on Friday, then it will be on Monday. And here is the Dropbox Smartboard file for the next like 5 lessons. So I'm going to show you that right now. And then next week we'd be doing modules 1 and 2 of Unit 7. So let's go ahead and get into it. The Smartboard file looks like this. And here would be Module 1, Session 2, that all you're doing with them is working through 2 word problems and then practicing. So the first word problem I have blotted out, so it'd go something like this with the kids. Jack bought a sheet of stickers with rows of stickers on it. The stickers cost cents each. Then you just have a discussion of making sense of the problem. What is happening right now in this Jack situation? Then you would reveal those numbers. Okay? And now, what do they think the question's going to be? So you have that discussion, and then you reveal the question. Just gets kids more into the problem. Then the main emphasis for this next week is writing equations first that would help solve the problem. So I scaffolded it for kids who would need it, and it kind of benefits the whole class at first. So our equation here looks something like this. So what do you guys think this variable C is representing? So then you have a discussion that it would be what, and then reveal it, the total cost in cents of the sheet of stickers. And then how would we get what that C is? What numbers would go in here? So then you have a discussion and you reveal, and then you would go forth and let them solve it. And then, have your discussion of how people solved it. Then you have a second one to do, same idea with your equation, what B represents, and then solving it. And then you go into practicing. And this is a student book page that I have copied for you, and I'll put in your mailbox, okay? If you like this one, okay? And then session 3 would be, this is module 1, session 3 and 4 combined. So I put these together because they kind of went well together, and the main idea is multiplying with 11s and 12s by making use of the linear units. Now, whether you have kids actually touch and use the linear units is up to you. I've made the file to where they could manipulate it on the Smartboard file. So you're going to warm up every day though with a word problem and coming up with an equation first without it being given now. The scaffold's not there. So they come up with their equations, you have a discussion of theirs, and then you reveal these 3 and discuss how each one could represent the situation. And then after you have that discussion, whether you think you have time to go there, you'd go forth and solve, or you just skip the solving part because the main emphasis is on discussing the equations. Then we get into the 11 and 12 investigation. So first you want to have them get the idea that if you just laid out a lot of linear units, it's going to take longer to count. So first you give them this image, say how many do you think that is? It's going to take them just 10 seconds maybe, and then show this image. It's the same amount, but it's easier to count. Why? Okay, so that rolls into and leads into the investigation of 11s and 12s. So now we go through our 11 as a factor with our picture here. So I have 11 in our array right now. It's an 11, so you want to talk about the dimensions, an 11 by 1. And that's what we have here, an 11 by 1, which gives us how many squares? 11. Now let's go to 2 by 11. So what's nice here is I made this an infinite cloner, so you just drag a group of 11 down right here. And now I have 2, dimension of 2 by 11, which gives us 22. And then we go to drag another one down, 3 by 11, and keep going through this whole list so that you guys can get some numbers going and patterns going and kids talking, okay? And then same idea with the 12. So here's a 1 by 12, and then this should be an infinite cloner. So I'll have to change that on there. It's there. And then I'm going to drag it down. 2 by 12, 3 by 12, 4 by 12, same thing. Okay, so you have that discussion. And now they're going to go to their practice page and they're going to practice what they just saw. Okay, so this is also going to be in your mailbox of a practice page that I thought went well with it. And so they're labeling the dimensions of the array that they see and then writing out 2 equations that would go with it. Okay, then you go into session 5 from module 1. And so again, you start with the warm-up, focusing on the equation. Okay, they come up with theirs, then you reveal these 3, and you have a discussion of why these would also represent the situation. Okay, then the exploration today is multiplying multiples of 10 by single digits. So you're going to start by the single digit of 6 and exploring what happens when you multiply 6 by multiples of 10. So you look at this example together, and then they will have this handout and they write in 20 by 6, what happened? 30 by 6, what happened? Okay, and then 40 by 6. And then using that information to solve these, so they can start seeing the patterns. And then they're going to explore more on their own, so they get to choose a number between 4 and 9, not the one you just did, and they're going to explore their single factor. Okay, and then after they've explored it, there is another practice page, whether you want to use it or not, multiplying by multiples of 10. So I'll put that in your mailbox if you want to use it. And then we go on to the next session, which is combining module 2, sessions 1 and 2 together. Again, warming up with an equation, them coming up with it, and then discussing how these would work in the situation. And in this particular day, you have a problem string to do with them. So the first one being 5 times 3, then 5 times 10, which then leads into 5 times 13. We can get 5 times 13 by adding together the products of 5 times 10 and 5 times 3. So it is worth writing the equation of 5 times 10 plus 5 times 3 equals 5 times 13, and showing what happened. We can see the factor of 5 in here, but what happened to the 13? Well, it got split up to make it easier in our head. It would also be beneficial in this problem string to draw out the arrays so they can see them coming together and have a visual for that. And then you go to 5 times 20. How can we do 5 times 20 from what we have up here? By using this 5 times 10 and doubling it. And then you go to 5 times 23. And 5 times 23 we could get by using this one and using the top one up here. So it's all about those partial products. Then you go into the building and sketching arrays. I kind of took out the building part of it, but you could have that option of having the kids build it if you want. My idea was give them this problem with this picture of the array already built, and they have to figure out why is this one representing this situation. Then once you have that discussion, then they would use their grid paper, or just you up on the screen, would then draw out this array, what that looks like on grid paper, okay, and solve the problem. Then you have another one to do, same idea. How does this picture go represent this situation? Now you guys, we're going to draw it and we're going to find that product, okay? And then they try, right? They try one and try another one, and there's more multiplication practice for you if you want to use it. Okay? Then the next session would be Module 2, Session 3, which is mystery arrays. And you start off the session with a problem string. So you have same idea as last time, 6 times 10, 6 times 4, guess what it's going to be? 6 times 14. And then we go to 6 times 20. And then 6 times 30. And then is there one more? Probably, because it keeps going 6 times 34. Okay, a little extension from the day before. And then it's called mystery arrays because you're going to show them. Oh, whoops, the problem string keeps going, guys. Okay, all right. Deal with it, right? Yay! Problem string is the long one. Okay, so, but partial products is so critical. Like, it is really powerful if a kid can understand that. So it is actually good to do a lot of those. So here is a mystery array. The mystery is because there is no linear units in here. So they're trying to figure out what is the multiplication problem that's being given here, and what's the answer to it. So they could have the linear units with them at this point if you want to be able to make it, or they have their whiteboards and they're trying to write equations to figure out that total. And then you reveal it with the grid paper and you guys trying to find that answer. Okay? And then you have another mystery array to try. And then they make their own mystery arrays. So go ahead. I only have a couple minutes left of this recording. So they get to make their own mystery array on the table made out of linear units. And they have to, you know, fill it in with area pieces to find that product. And they have to make their sketch on a sheet of grid paper with the answer and equations with it. And then they take out the linear units, if they even used them. Not linear units, they take out the area pieces, the yellow pieces. They take those out, and then all that's left is their blue linear dimensions. And then kids can hop around to different areas of the room and solve each other's. So if I go to one person's linear dimensions, I would be on grid paper trying to figure it out. And then if I want to know whether I got it right, I would then flip over the grid paper from that person to see if I got it right. So it's kind of cool, hopping around doing kids' problems. Okay, and this guy's example, his name was Tuan. I found that interesting. Okay, so that is that. They are playing the mystery game right there. Look like they're having fun too. Okay, if you have questions, just email me, people. Okay, bye.